All right, class. This is the lecture on force and acceleration. At the end of it, I'll also do work through some problems. So we're getting into, let's see, rigid body kinetics. And we're specifically doing the force acceleration method. So basically with this, we'll use sort of a similar method for this. But basically we're going to look at whatever the system or the mass or whatever the thing is that we're looking at, and we're going to set the free body diagram equal to the kinetic diagram. And basically the reason that we have to do this is because in these problems we have stuff that's moving. So whereas before, previously in statics we could do the sum of the forces and the x direction equals 0, and sum of the forces in the y and the moment equals 0. But now we're dealing with stuff that's moving, so that it's no longer 0 anymore. So that's the reason that we'll do it this way. And this method makes it a little bit easier for you. So let's say we have this rigid body, and we have our free body diagrams. This is what we're drawing on the left. So we have the weight, and that's acting at the center of gravity. We have some other forces. So let's say we have AX, AY. We have this force B, and we have this force P. Oh, and the C isn't the center of gravity. The C is actually a couple. So we have a couple here, or a couple acting on the body. And then we're going to set this equal to a kinetic diagram of the same system. And so for both of these, we're looking at the problem statement and the diagrams that were given and trying to figure these out. So now we're doing the same. We have the same system or whatever. So didn't draw it that well, but those are the same shapes, or should be. And now we're doing the kinetic diagram. And so with the kinetic diagram, we basically want to write down anything that's acting on that. So we have our center of gravity here. For this one, we can have the mass times the acceleration about that point G in the y direction. And then we can have the same for the x direction. So mass times the acceleration around that point G. I'll write that point G in the x direction. And then we can also have the inertia. So I sub G times alpha, times that angular acceleration. So this mass moment of inertia, the I, it's actually to help you sort of understand the rotational aspects of the that are caused by a moment. So just so you know, so a moment equals I, so that's mass moment of inertia, times alpha, which is that angular acceleration. So that I is the mass moment of inertia, and it's a measure of the resistance of a body to angular acceleration. So I'm going to erase that, but just to give you an idea of what that is. So basically what we can do now is we can set up our equations. I'm actually going to make this a little bit smaller. Make that a little smaller. Sorry about that pause. But basically this will allow us, by setting it up and drawing it this way, it'll allow us to easily set up our equations. So with this, we can pretty easily go, okay, we've got the sum of the forces in the x direction equal that MAGX. If in this case there wasn't an acceleration in the x direction, then that would just be 0. And then we can also do the sum of the forces in the y direction equals MAGY, and the sum of the moments about G, by that center of gravity, equals that mass moment of inertia times alpha, times the angular acceleration. So basically by setting it up or drawing it this way, it makes it super easy to sort of pull out all of the equations that we need. It's not a big, we're not talking a big difference from what you've done already. So I'm just going to move these. So with the kinetic diagram, so in the case of the kinetic diagram, we can have, we'll just call them KD. They can have a max of 3 terms. Those are those 3, MAGX, MAGY, and IG times alpha. And it's always at the mass center. So it's at the center of gravity. And it's the mass times the acceleration about G, whether it's in the x or the y direction, always. So for this, it's important, and this is why we did those centroids and stuff. It's important for us to know where the center of gravity is. For the kinetic diagram, it's always about that G, or about that mass center. We can do, so the way that I just set this one up, I used Cartesian coordinates, so x and y. You don't have to use x and y. Some other options, let's see. We have a choice of coordinate systems. They can be Cartesian, like we just did. They can be perpendicular and parallel, or they can be normal and tangential. Sorry, that was not written very well. Normal and tangential. And